Good morning everyone. So today we're going to talk about DNS, that is domain name system. So basically a user wants to use a file transfer client to access the corresponding file transfer server running on a remote host. The user knows only the file transfer server name such as afilesource.com. However, the TCP IP suite needs the IP address of the file transfer server to make the connection. The following 6 steps map the host name to the IP address. The user passes the host name to the file transfer client. The file transfer client passes the host name to the DNS client. Each computer, after being booted, knows the address of one DNS server. The DNS client sends a message to a DNS server with a query that gives the file transfer server name using the known IP address of the DNS server. The DNS server responds with the IP address of the desired file transfer server. The DNS server passes the IP address to the file transfer client. The file transfer client now uses the received IP address to access the file transfer server. Now let us talk about namespace. A namespace that maps each address to a unique name can be organized in two ways, flat or hierarchical. In a flat namespace, a name is assigned to an address. A name in this space is a sequence of characters without a structure. The main disadvantage of a flat namespace is that it can't be used in a large system such as the internet because it must be centrally controlled to avoid ambiguity and duplication. In a hierarchical namespace, each name is made of several parts. The first part can define the nature of the organization, the second part can define the name of an organization, the third part can define departments in an organization, and so on. Now let us talk about domain namespace more. To have a hierarchical namespace, a domain namespace was designed. In this design, the names are defined in an inverted tree structure with the root at the top. The tree can only have 128 levels, that is from level 0 to level 127. Label. Each node in the tree has a label which is a string with a maximum of 63 characters. Domain name. Each node in the tree has a domain name. A full domain name is a sequence of labels separated by dots. Domain. A domain is a subtree of the domain namespace. The name of the domain is the name of the node at the top of the subtree. Note that a domain may itself be divided into domains. Distributed namespace. The information contained in the domain space must be stored. Hierarchy of name servers. DNS allows domains to be divided further into smaller domains. Each server can be responsible for either a large or small domain. In other words, we have a hierarchy of servers in the same way that we have a hierarchy of names. Let us talk about zone. Since the complete domain name hierarchy can't be stored on a single server, it is divided among many servers. What a server is responsible for or has authority over is called a zone. We can define a zone as a contiguous part of this entire tree. If a server accepts responsibility for a domain and does not divide the domain into smaller domains, the domain and the zone refer to the same thing. Now let us talk about root server. A root server is a server whose zone consists of the whole tree. Primary and secondary servers. DNS defines two types of servers, primary and secondary. A primary server is a server that stores a file about the zone for which it is an authority. It stores the zone file on a local disk. DNS is the internet. In the internet, DNS is a protocol that can be used in different platforms. Generic domains. The generic domain define registered hosts according to their generic behavior. Each domain in the tree defines a domain, which is an index to the domain namespace database. Thank you.
Good morning everyone. Today we are now going to continue with the explanation about application layer, which is the topmost layer of an OSI model. This layer acts as a bridge between the user and the network. In simple terms, this is the layer that is interacted with the networked application like web browser, email clients, etc. Now, the application layer is the seventh layer of the OSI model. It provides network services directly to the end users, unlike other layers that doesn't deal with transmission or routing. Instead, it focuses the interface and protocols needed for communication. Some common services that application layer provides are the email services, file transfer, web browsing, domain name resolution, remote login, etc. Now, we also see that the application layer ensures that the data is properly formatted for transmission. For example, when you open a web page, your browser uses HTTP to request data from a server, and the application layer ensures that the web content is properly displayed to you. Now, talking about the technical terms of the application layer, it identifies communication partners, meaning it finds the right network resource or destination for communication. Now, it also determines the resource availability and synchronizes communication. For example, when you send an email through the Gmail app, the application layer uses SMTP to send the message, while receiving mail server using POP3 or IMAP to retrieve it. So the process of sending, receiving, and displaying messages is managed by the application layer. Moving on, we also see that the application layer is what makes network communication user friendly, accessible, and without it we couldn't browse websites, send emails, and or transfer files easily. It's the layer that connects human interaction to network technology, making communication seamless and understandable. So now we will see that how the application layer helps us. Now we will see the main services and protocols that are handled by the application layer, which includes HTTP, HTTPS that are used for accessing and displaying web pages for the internet. For example, when we visit a website, like the browser sees HT or HTTPS that request data from a web server. And secondly, we have SMTP, POP3, IMAP, which are the email communication protocols. Thirdly, we have the FTP, that is a file transfer protocol, and SFTP, secure file transfer protocol, which are used to upload or download files between the computers. Moving on, we have the DNS, that is a domain name system, which converts human readable domain like google.com into IP addresses like 142.250.190.14, etc. And lastly, but we have the telnet and SSH, which are used for remote login and accessing other computer over a network. Each of these protocols help a specific type of application communication efficiently over the internet. Now we'll see the functions of the application layer. The functions are there are six type of function apart from the main key functions, that are the network virtual terminal, which allows the user to log on to a remote host, telnet and SSH to use this concept. The others are file transfer, access and management, mail services, directory services, data formatting and translation, error handling and synchronization. So, in the end, I would like to say that the application layer is the face of network communication, where what allows us to actually use the internet and network services. It provides all the tools and protocols that the network makes meaningful to the humans. Without it, the network would still transmit data, but we wouldn't be able to interact with it in a useful and understandable way. So, in short, the application layer is what makes the network usable, accessible, and intelligent for everyday tasks like browsing, emailing, or streaming video. Thank you.
Good morning. Now I am going to speak about simple mail transfer protocol, post office protocol, internet message access protocol, file transfer protocol. There are four essential communication protocols that play a major role in the exchange and management of data over computer networks, particularly on the internet. SMTP is primarily used for sending and forwarding emails between mail servers. It operates at the applications layer of the TCP IP model and typically use port 2587. SMTP works on a push-based mechanism, meaning that it pushes emails from the sender's mail client to the email server and then from one server to another server. It ensures the reliability of email delivery through acknowledgement and retransmission mechanisms, verifying that each message reaches its correct destination securely and efficiently. In contrast, POP and IMAP are used for receiving and managing incoming emails. POP3, the most common version of the post office protocol, operates on port 110 and follows a pull-based mechanism, where the user's email client downloads messages from the mail server onto their local device. Once downloaded, the emails are typically deleted from the server, allowing the user to store and access them offline. This method is suitable for individuals who prefer accessing emails from a single device. However, the The traditional approaches has limitations in terms of synchronization across multiple devices, which is where IMAP becomes advantageous. IMAP operating on port 143 provides more flexibility by allowing users to access, read, and organize their emails directly on the mail server without needing to download them. IMAP maintains synchronization between the server and all connected devices, ensuring that any change made, such as reading, deleting, or moving an email, is reflected universally across all platforms. This makes it deal for users who access their mail for multiple devices like smartphones, laptops, or tablets. In essence, SMTP manage the sending of email while POP and IMAP handle the retrieval and management of incoming messages. It supports both active and passive modes to accommodate different network configurations and firewall settings. FTP is especially important for web developers, system administrators, and organizations that need to exchange large files efficiently. However, since standard FTP transmits data in plain text, including usernames and passwords, secure versions like FTPS and SFTP. In conclusion, SMTP, POP, IMAP, and FTP collectively form the foundation of internet-based communication and data exchange. SMTP ensures the reliable sending of emails. POP and IMAP enable efficient retrieval and synchronization of SMTP POP. Thank you.